Another thing we also need to consider about different sources of energy is how safe they are. In this video, we're going to compare different sources of energy and look to see which ones are the safest for human health. When we're looking at how energy production can harm people's health, there are two really important factors that we want to consider. The first of these are accidents that might arise from mining or extracting the fuel that we need to power the plants to getting it to those power plants. So accidents would include things like coal miners that are harmed in accidents as mines collapse, and would also include accidents that are caused by moving that coal around through train or through transport truck. Another thing we also have to consider is that the construction of power plants and operating them can be dangerous as well. So these accidents would also include people who are injured or killed as they construct a power plant, or who are harmed in industrial accidents that happen at the power plants. Another thing we also need to consider is air pollution. Air pollution isn't something that's just unsightly, but breathing it in can cause a whole host of problems. So we've been concerned a lot about greenhouse gases in this course, but it turns out that there's a lot of other things that can be emitted as we burn fuels as well. So carbon dioxide is not that harmful when we breathe it in, but some of the other stuff that's produced by the burning of different fuel sources can absolutely harm our health when it gets out into the air and we breathe it in. When we talk about the safety of different energy sources, one thing people want to consider is serious nuclear accidents, and the world has had two of them in recent history. The two most recent accidents have happened at Chernobyl in the Ukraine in 1986, and the second most recent one was in Fukushima, Japan in 2011. Meltdowns are a form of industrial accident in a nuclear power plant where the cooling system basically fails to operate. And what ends up happening is that the nuclear reactor in the core basically goes out of control and generates such incredible amounts of heat that it will destroy the plant and potentially release a lot of nuclear fallout. So nuclear energy and nuclear fallout is very dangerous for our health. It can cause all sorts of cancers. It can damage our DNA. So obviously having a really serious accident like a meltdown would be a really serious problem for people's health, potentially. What we know about these two really serious nuclear accidents is that they did kill people, but the death count is not necessarily as high as a lot of people assume. Hannah Ritchie, who's a data scientist and who does a lot of the work that we'll be seeing in this class, did research on both of these nuclear accidents and estimates that the nuclear power plant meltdown at Chernobyl likely killed about 500 people, while the more recent one in Fukushima, Japan, probably killed about 2,300 people. But as she admits, these estimates are very difficult to judge if they're fully accurate, because there's a lot of issues when we're doing research about the causes of death from an accident like this. So 2 points that she stresses is that it's very difficult for us to track long-term effects such as cancer that might be caused by radiation. In her research on both of these nuclear accidents, she takes the approach that she's going to count most of those cancers related to the meltdown as actually being caused by the meltdown. But one of the things that we know is that people develop cancer for other reasons. So it's very tricky to know if people who might have been living near Chernobyl or Fukushima, if they developed cancer, if it was because of the nuclear power plant or if it were for some other reason. So this is a bit difficult to estimate because some of those long-term effects, it can be a little muddy to try to figure out what might have caused them. Another point that she brings up, particularly in the context of the Fukushima accident, is that the failure of the core and the meltdown in that instance was actually caused by a serious earthquake and a subsequent tsunami. So a giant wave basically crashing over the area where Fukushima was sited. And there were a lot of deaths that were associated with both the earthquake and the tsunami as well. So many people who are close to the Fukushima power plant may not have died because of the nuclear power plant failure, but may have died as a result of these other problems that were happening at the same time. So again, it's very tricky to figure out what might have been the ultimate cause in these cases, because again, the earthquake and the tsunami were two of the things that contributed to the meltdown. Nonetheless, this suggests that nuclear power can be dangerous, but we do want to be careful about these numbers here. While we do not want to minimize people being harmed by any kind of accident, basically, a nuclear power plant accident is a lot easier to see than some of the invisible deaths that can happen. And we don't necessarily hear about the person, for instance, that's harmed and killed when they're doing their work at a nuclear power plant, doing their work at an energy plant. And we don't necessarily hear about the people who die as a result of breathing in some of the pollutants that are created by these sources of energy. So one of the key points that we want to take from this is that this is absolutely serious, and these could have been much worse accidents potentially, but nuclear power is not necessarily the most dangerous form of energy production. Now, one thing we do want to consider is the effects of air pollution that are caused by energy production. One of the things that can happen is that we can create smog as a result of the pollution that's being released. Smog is basically created by ozone when it mixes with a lot of pollutants at higher temperatures. And smog looks like smoke, or it looks like fog, which is actually where the name comes from. So, in addition to looking very unsightly, it can actually be quite dangerous to breathe this in. Another thing we also have to worry about is particulate emissions, and in particular, something that's called PM2.5. PM2.5 gets its name based on its size, and these are substances that are 2.5 microns or smaller that we can breathe in into our lungs. Now, this image here shows grains of sand, a human hair, larger particulate matter, PM10, and compares the size of it. So looking at this scale, you can see that these materials are extremely small. And they're not only released by burning different kinds of fossil fuels, but this is one of the reasons why we've had a lot of health advisories from recent forest fires. When forests burn down, they also create a lot of PM2.5. When we breathe this in, we do not really effectively filter it out. So, like for instance, our nose hairs can't necessarily deal with a lot of this, and it can get stuck in the really delicate tissues in our lungs. So for this reason, these kinds of emissions are also very harmful to human health. And we want to consider them when we're considering what the safest and most dangerous sources of energy might be. So one of the serious health problems that both smog and PM2.5 can cause are asthma and lung-related conditions. So people have died because of asthma attacks that have been brought on by breathing in severe pollution, and their overall health and their lungs can also be harmed over the long term. We also know that smog can cause different forms of premature death. So we don't necessarily know exactly what the cause of death is, but people in really polluted areas can sometimes die younger than we might expect. We also know that PM2.5 is associated with different heart problems. So arrhythmia, or irregular heartbeat, is one of the conditions that can be caused by PM2.5, as well as heart attacks. Both of these things can be fatal. And so one of the things that can happen is that we're breathing this stuff in, and basically it goes from our lungs and it starts getting circulated around our body, and it can cause heart damage as well. So air pollution is very harmful, and it's not just something that's inconvenient or that causes things like allergies, but it can actually cause death in many different forms. So one of the things that the data scientist Hannah Ritchie, who I mentioned a couple of slides ago, did is she compiled research on different forms of accidents and air pollution that were caused by different kinds of energy production. And she's ordered them from the most dangerous to the least dangerous forms. Now, in order to correct for the fact that some sources of energy are larger than others, she basically looked at the number of accidents that are caused by generating a terawatt of electricity. So this is basically correcting for the fact that the world has more coal, and it basically allows us to compare the different sources of energy despite their differing sizes. What she finds is that coal is the most dangerous form of energy production. It causes the most pollution, it causes the most smog, and that's contributing to a lot of those problems. But it's also contributing a lot in accidents as well. So coal mining, for example, is quite dangerous. And so what we know is that coal and brown coal are very dangerous. Now you might be wondering what's the difference between these two things. Brown coal, or lignite, is a particularly dangerous and dirty form of coal. So this is basically the dirtiest fossil fuel that we know, and that gets burned regularly in power plants. Oil is more safe, but it still causes quite a few deaths. And biomass, which would again be things like burning of wood, is quite dangerous as well. One of the reasons biomass is also dangerous is that in poorer countries where people are using wood to cook their food indoors, they're releasing a lot of that particulate matter into their homes, and they're causing asthma and other health conditions as a result of breathing that smoke in when they're cooking. Now, natural gas is relatively safer, but as we've pointed out previously, it still has the problem of high emissions. When we get into the cleaner sources of energy, hydropower is even safer than gas. Wind, nuclear, and solar are the safest forms of all. So again, one of the things that we want to keep in mind is that not only do fossil fuels and biomass release more emissions, they also are causing more health problems from pollution as well. And hydro, wind, nuclear, and solar power, they have no emissions at the source of their plant. And again, this is because the fuels that they use are not releasing greenhouse gases. And we know, as a result of this, that they're causing almost no air pollution deaths or accidents. What these numbers largely account for when we're looking at hydro, wind, nuclear, and solar is that these are primarily accidents that are caused by building and maintaining these plants. They're not causing air pollution, and the few deaths that they are causing are primarily from the construction and the maintenance of these power plants. So, to kind of wrap up this video, we do want to pay attention to really serious nuclear accidents like the ones that happened at Chernobyl and Fukushima. We do not want to minimize nuclear safety because if we start building nuclear power plants and they're not safe, we could start seeing more accidents happening in those plants. But when we look at nuclear power in historical perspective, as serious as those accidents were, they often pale in comparison to the kinds of deaths that are being caused by air pollution and other forms of accidents. In particular, air pollution can seem very invisible. We don't know about a big event that kills a lot of people when people are coming down with heart attacks or they're having asthma attacks. These are things that are spread out and they're more diffuse, and as a result, they're harder to see. But just because they're harder to see doesn't mean that they're not happening. And what happens when data scientists and researchers compile information about different sources of energy and how they're contributing to premature death, a lot of our fossil fuels are not only releasing a lot of greenhouse gases, they're releasing other things that are not good for people's health as well. One of the things that Richie points out in her research on these things is a rather encouraging sign, because the trade-off between the safest forms of energy and the ones that solve global warming doesn't exist. Basically, if we adopt solar, wind, hydroelectricity, and nuclear, not only will we have fewer emissions, but we will have fewer deaths from pollution and accidents as well. So in her words, the good news is that there is no trade-off between the safest sources of energy in the short term and the least damaging for the climate in the long term. They are one and the same. In other words, the sources of energy that are the safest also tend to be the ones that cause the fewest deaths and the least amount of harmful pollution.